Ever trained a machine learning model and thought, is this really the best it can do? What if I told you that your model might be underperforming simply because of how you split your data or choose your parameters? Today I'll show you how to unlock your model's full potential using k-fold cross-validation technique and further to GridSearchCV, the ultimate hyperparameter tuning technique. So guys, let's start with a simple question. Why do we split our data into training and test set? To evaluate model performance, right? But what if that split is biased? What if your model performs well simply because it got lucky with your data? That's where k-fold cross-validation comes in. Instead of relying on one set, k-fold cross-validation will divide the training data set into k parts, say 5 or 10, and trains your model k times using different validation set. This gives you more reliable estimate of how well your model will perform on unseen data set. Now that we have solved the problem of biased evaluation, let's go to the next big thing, that is hyperparameter tuning. So these were the settings you manually choose earlier, like max depth, min sample leaf, min sample split. But how do you know which combination will be the best? Let me introduce you your model's personal assistant for finding the best hyperparameter. It runs your model on every combination of hyperparameters using k-fold cross-validation technique and tells you which combination of parameters performs the best. It's like having a smart assistant who tests every possible settings and gives you the winning formula, all while keeping evaluation fair and biased. So guys, let me put this theory into meaningful coding. So guys, when I say coding, you can do it on different platform. I am using Anaconda. You can see here, this is Anaconda Navigator. What I have done is I have launched this Jupyter notebook and I've got this. So let us revise the decision tree from the start, because the libraries are essential for finding out trained data set. So let's start with 0 by importing required libraries. So we have imported pandas as PD, numpy as NP. We have imported matplotlib.pyplot as BLT, cbound as SNS, pd.read_csv, and we could see the columns. These are all columns. We can display the first 5 rows also. Now we have put feature variable to x, means we want this data frame without heart disease. So what we have done, we have dropped this heart disease. We have assigned the heart disease to y variable. Then we have to import the train test split. So from sklearn.model_selection import train test split. As we saw earlier, we have allotted train size or train data as 70%. So you can see the shape also. From sklearn.tree import decision tree classifier. So now we are importing decision tree classifier, and we have fit the x train and y train data. These libraries we have used for visualization, and these commands we have used for plotting. We got this tree. Now we'll predict the y train and y test, and using confusion matrix and accuracy score, we will check the accuracy score and confusion matrix of train and test data set and will compare. So earlier we have done this also. We have defined a function for plotting of graph, we have defined a function for model evaluation, and we have seen different decision trees using different values of hyperparameters. Okay. Now we will see how GridSearchCV works. So dt equals decision tree classifier, wherein we have assigned random state equals 42. So this decision tree is without any hyperparameters. This tree is without any hyperparameter because we will be providing hyperparameters later. Okay. So from sklearn.model selection, we will import GridSearchCV, and we will create the parameter grid based on results of random search. So we will assign the different values of hyperparameters to params. Okay, so this is how we are doing. So this is basically dictionary, key value pairs, min sample is key, these are the values, max depth is key, these are the values. Now we will instantiate the grid search model, grid_search, we will assign this variable, and with this estimator we will put the dt as the estimator, because dt is our decision tree model. Param_grid, we will assign this to params CV is 4, it means the whole data set shall be divided into 4 fold. Okay, so 1 fold will be used for evaluation and 3 folds will be used for training data set. And jobs equals -1 means it will assign all the cores of the computer, and scoring we will be taken as accuracy. We will also calculate the time which this grid search is taking. Now let us fit the model. After fitting the model, it says 4 folds for each of 50 candidates totaling 200 fits. So how this 200 is coming? Max depth is, there are 5 values. For min samples leave, there are 5 values. For criterion, there are 2 values. So you multiply it 5 into 5 into 2, that is total 50. And as we have done 4 folds, it means there will be total 50 into 4, that is 200 fits. So this is how it is calculating. Using grid_search.cv results. CV results is the command which is required to find out the split scores. We convert this split score into a data frame which we can read it easily. This is the data frame. Now let us try to find which is the first 5 largest mean test score. So you can see here there are this one, this one, this one, this one. These are the 4 folds. The distribution is like this, and we have got this mean test score. So we will find out the largest 5 mean test score. Also we can find out the best estimator, and we will assign this variable as dt underscore best. So for this grid search we need best estimator, right? Now we will evaluate the model. So evaluate underscore model dt best. So this evaluate underscore model will call which function, which we have already defined. This one. This function will be called there. So it will find out the train and test accuracy and confusion matrix also. So the train accuracy is 72% and test accuracy is 62%. The overall model is quite good fit. You can also take more values of max depth and min samples leave to find the more accurate model. We will import classification report. So from Scikit-learn.matrix import classification report, and we will print this classification report with the predicted test data set. So you get precision, recall, F1 score, support. Now we will create the tree using the best parameters which we have chosen. So this is the function which is called, and this is the command for creating the PNG. So you can see here this is the similar tree which we have got earlier. So this tree is the best tree based on these parameters. So this is how you can use GridSearchCV to get the best tree. So friends, you saw how coding works in GridSearchCV. So next time you build the model, don't just train and test, validate and tune using GridSearchCV and k-fold cross-validation technique. So your model, your optimized model, your best model. Please subscribe, like and comment the video. Thank you.